Hello class, section 1.5. We're going to talk a lot about equivalent fractions. And equivalent fractions just means that they're basically equal to each other, but with different numbers. So you know that 1/2 equals 2/4 equals 10/20 equals 9/18 equals 23/46. All of these are pretty much the same thing. It's just that 1/2 is what you would get with all of these when you reduce it, which is what normally you're going to have to do. There's going to be some of these where you are going to what I call unreduce, and that's what we're going to use later when we have to add and subtract fractions. So let's say that we have a number 10/3 and we want it with the denominator of 18. So what we're going to do is, how many times does 3 go into 18? So 18 divided by 3 is 6. So what we're saying is 3 times 6 equals 18. So we also have to multiply the top by 6. So what we could say is 3x, how many times, or 3 times what equals 18, and x is 6. So 10 times 6 is 60. So our answer is going to be 60/18. So if we want to do an equivalent fraction of 10/3 with the denominator of 18, it's going to be 60/18. So now we're going to do what we do normally, and that's reduce. So let's say that we have 525/420. What we need to do is just find some number that will divide into both of these numbers. And in the past, you may have been told to always use the least common denominator. Sometimes that's good, but sometimes you don't really need to do that as much. So what I'm going to do is just find any number that will divide into both of those. And it's what we did in the previous section where we said that a number is divisible by something. So here we see that 1 is a 5 and a 0. So we know that both of them are divisible by 5. So what I'm going to do is divide both of these numbers by 5. When I do that, I'm going to get 105/84. Now we need to see if some number will go into both of those. And if you remember what I said, we can check for number 3 by adding the digits. 1 plus 5 is 6. That's divisible by 3. 8 plus 4 is 12, and that's divisible by 3. So I'm just going to divide both of these by 3. When I do that, I'm going to get 35/28. And we can see here that both 35 and 28 are divisible by 7. So our final answer will be 5/4. Now you could have divided both of these originally by 105 and got the answer in one step, but this just shows that you don't have to find the greatest common or the least the greatest common divisor for these. So let's say that we have okay, so that's just simplifying. Now let's say that we're going to multiply fractions. Say we have 4/5 times 3/7. What we do here is we just multiply the numerators to each other and the denominators to each other. So 4 times 3 is 12, 5 times 7 is 35, and we can't reduce this anymore. So that's our final answer. However, I'm going to do this one two ways. I'm going to say -3/10 times 8/7. So the first one I'm going to do is just multiply straight across. So negative 3 times 8 is negative 24. 10 times 7 is 70. Both of these are divisible by 2, so we would get negative 12 over 35. However, what we can do is simplify before we multiply. The reason I would prefer that you do this is because when we get into expressions with variables, you have to simplify before you do the multiplication, or it's way too hard. Plus, it makes it easier as far as the numbers go. So we're going to start again with negative 3 over 10 times 8 over 7. And what we're going to do is look at numbers that are on both top and bottom to see if we can reduce them. So here we have an 8 on top and a 10 on bottom. Both of those are divisible by 2. So I'm going to divide the 8 by 2 and the 10 by 2. When I do that, I'm going to get a negative 3 over 5 times 4 over 7. And now when I multiply negative 3 times 4, I get the negative 12, and the 5 times 7 is 35. So you see I got the same answer doing it both ways. This second way does make things a lot easier when you have harder numbers. And that's why I recommend always using it. You don't have to, but once we get into numbers that have variables with them, like x squared plus 2x plus 1 over x plus 1, you really need to, and then times x plus 3 over x plus 1, you really need to simplify before you do anything else. So now let's see what happens when we're dividing fractions. Say we have 6 over 7 divided by 7 over 9. Here what we're going to do is flip the second one by giving the reciprocal and then multiplying. So this becomes 6 over 7 times 9 over 7. And we can't simplify anything here, so 6 times 9 is 54, 7 times 7 is 49. Note that I did not simplify the 7 and the 7 before I multiplied. You can only do that when you're, or before I flipped it. You can only do that when you're multiplying, not when you're actually dividing. So that being said, let's say that we have 6 over 7 divided by 9 over 7. It's the same numbers except I flipped this one. So now to make it into multiplication, I do the reciprocal of the second number. So this becomes 6 over 7 times 7 over 9. Now I can simplify the 7 and the 7. They both are divisible by 7 and we get 1. And we can also simplify the 6 and the 9. So I'm going to divide this by 3, this by 7, this by 7, and this by 3. When I do that, I'm going to have 2 over 1 times 1 over 3, which equals 2 over 3. So again, it does make it a little bit easier to do your simplification before you do anything else, especially on this next one. Say we have 77 over 72 divided by 99 over 68. So the first thing I'm going to do is flip the second one. We'll have 77 over 72, and it becomes times 68 over 99. So the 77 and the 99 are both divisible by 11. And these two are both, the 78 and the 74 are both divisible by 4. So now when I do this, 77 divided by 11 becomes 7. 72 divided by 4 becomes 18 times 68 divided by 4 becomes 17, and 99 divided by 11 becomes 9. Now I can't do any more simplification, so I just have to do the multiplication. 7 times 17 is 119. 18 times 9 is 162. So that would be our answer there. Next, you're going to have some that have one fraction and one whole number. Let's say that we have 5 over 6 divided by 10. We want to do that the same way. What you need to remember is that whenever you have a whole number, you can say that that's divided by 1. So let's just write divided by 1. So now when we flip it, it becomes 5 over 6 times 1 over 10. Now the 5 and the 10 are both divisible by 5. This will become a 1. This will become a 2. So now we have 1 times 1, which is 1. 6 times 2, which is 12. Then let's say that we have a whole number divided by 2 4/5. Okay, so the best way to do this is to first change the 2 4/5 into an improper fraction. So this becomes 7 divided by, we're going to say 5 times 2 is 10, plus 4 is 14, and it's still over the 5. So now, again, we're going to change this to be a 7 over 1, and then it becomes times 5 over 14. Now the 7 and the 14 are both divisible by 7. This will become a 1. This will become a 2. So we have 1 times 5 is 5 over 1 times 2, which is 2. You may leave the answer like this, or the computer may say to change it into an improper fraction. If it does, you'll say 2 goes into 5 2 times with 1 remainder. So the answer would be 2 1/2. I think though that you would just leave it as an improper fraction. That's what you'll do most of these. Okay, you might have some also that are written in a different format. Say you have 9/14 over 13/4. So you're going to do the same thing. It's going to be 9 over 14 times 4 over 13. Okay, so now we can simplify the 4 and the 14, dividing by both of them by 2. So this becomes a 2, this becomes a 7. The only reason I'm doing that is to make the simplification easier. It's easier to figure out 7 times 13 than it is 14 times 13, and then see what number will divide into both of those. So anyway, 9 times 4 is 18, and 7 times 13 is 91. Next, you're going to have something that's a lot longer. Let's say that we have, in parentheses, 6 plus 4 times, in parentheses, 15 minus 7, all over 10 squared minus 80. So we have to do things in order of operations. So with the order of operations, you do everything in the numerator separately from what's in the denominator. So in the numerator, we have parentheses. So 6 plus 4 becomes 10 times 15 minus 7 is 8. And that's over. In here, we have an exponent. So we're going to say 10 squared is 100. And it's minus 80. So now we can do what's on top. 10, that's 15 minus 7 is 8. So 10 times 8 is 80. 100 minus 80 is 20. And 80 divided by 20 is 4. So I goofed here. 15 minus 7 is 8. So we should have 10 times 8 over 100 minus 80. We'll have 80 divided by 20 equals 4. Then we will have another complex fraction, but they'll be written over each other. So 95 over 56 divided by 15 over 62. So again, flip the second one, turn it into a multiplication. So we have 95 over 56 times 62 over 15. Now here's where it's really important to simplify first. And let me see, 15 times 5. Okay, so both 95 and 15 are divided by 5. And 62 and 56 are both divided by 2. So when we do this, 95 divided by 5 is 19. 56 divided by 2 is 28. 62 divided by 2 is 31. And 15 divided by 5 is 3. Oops, times 3. So now we can't really do anything as far as simplifying, so we have to multiply these big numbers anyway. And we're going to get 589 over 84. Okay, then the last type of question is a word problem. And it's going to be something like 3/4 of a yard of ribbon are cut into 24 equal pieces, and it's how many pieces? Or no, it's going to be how long are they? Okay, so here what we're going to do is 3/4 divided by 24. So again, remember that we can say that is 24/1. So to change it back to multiplication, we're going to say 3/4 times 1/24. We can simplify this. The 3 will go into a 24 8 times. So this becomes a 1. This becomes an 8. And 1 times 1 is 1. 4 times 8 is 32. So each piece is 1/32 long. And that's it for 1.5.